Hello, everybody. I am Taha M. Muhammad, USA Kurd, Iraq. I did solve a Euler perfect box in 3 ways. This is the third way. Abstract is this. By the way, my solutions of Euler, you can find it at Cambridge Opening Gates, UK, and at Orseed office also. And in my book, Amazon.com, Taha's collateral sequence. Okay, let me raise this Euler box high. Look at how I made very short the written statement by math writing. A, B, C, D, E, F, G, all are integers. If and only if we have Euler perfect box. If you have really Euler perfect box, then those 6 dimensions should be integers. What are they? A is the height, B is the width, and C is length, and E is diagonal for this face, D diagonal for the green face, F diagonal from top, and G interior diagonal from corner of a room top to the corner room ground, opposite side. 6 sides. How do I start? What shall I do? Do you see the picture what I am doing? When this is A, I told, let this is A plus unknown, R. And C also, this A, bring it here, A, and some unknown. But for sure, K is greater than R. But the relation between A and R, we have 3 possibilities. A equal R, A less than R, A greater than R. Okay, let me start. When you have A less than B, less than C, this is a normal box. Normally, we have a small and middle and very long. Small is here A, B middle, and C is the long. See? A smaller than B, B smaller than C. And I am telling here, let A not equal to R. And not equal to K also. R, K, not equal. Then B value will be what? B. This is B. Is A plus R. C value, A plus K. Okay? Now, since A smaller than B, smaller than C, you got what? Bring A here, substitute B, and substitute C, and cancel A from everywhere, you will get that. R smaller than a K. But A is unknown, less or more than R. Okay. By Pythagorean theory, we know G square is D square plus C square, as you see. This is C, and this is D, and that's one hypotenuse. And equal G square equals D square plus C square. And Pythagorean also at this page, D square equals A square plus B square. Okay, and this is the box I made it some change, you see? Okay. Now, let me go what's going on. Okay. Then when you do another substitution from G, you will get G squared equals A squared, and B squared plus C squared. This came instead of, I think, D, something like that. Anyway, do another substitution. B is AR and C is A plus K by substitution. Okay. I am thinking about this G square. Real square? It is like 8 or like 9. If it is 9, good. 16, good. But 8, 7, not good. How I know that? Okay, let me see. We are here. But if G square, we are familiar with kind of this square. If G square equals A square plus the root of A squared is A, multiplied by 2. Okay. Multiply AK, that means A plus K is here, has a square. This is 100% a square, we know that. Familiar with that. And I thought this one, let it is square. Do you see? N sub square, equation 1. We know 100% this is square, equation 2. Okay, that means suppose when G are same, and this is square, I am not sure from that now, but I told let sometimes true, sometimes not true. Okay, A square is here, and A plus K square is here, and the middle should be same value. Is A plus R square equal to A times A plus K? How I know? In algebra, 6th grade student can understand. 2 expression algebra, they are equal or not equal. You tell A is 2, B is 5, like that. If you got same number, yes. For entire numbers, for all natural numbers should be the same. Okay. Now, then I got this, A plus R, the middle, in the first equation, equal 2 times A plus K in the second equation. I told this expression is equation 3. That's okay. I have to take 2 possibilities. Remember, A sometimes smaller than R and sometimes bigger than R. Let me take a smaller one. And I know R also smaller than K. And let's start from here. See, A3 smaller than R, 4. And R is smaller than K, 5. You cannot tell 5 is 2, and you have there, you know, R is smaller than K. You have to follow the rule above. Do you like to see the rule above? Relationship between R smaller than K always, and I am taking this, A is smaller than R. That's why I told number 1. I told I. Okay, A smaller, take it 3. Then R 4, and R smaller than K, 5. Go ahead and tell equation 3, left-hand side, substitute, and right-hand side, substitute. You got what? 49, 48, 2 different numbers. This is proof that this expression algebra is not equal to this expression algebra. See? Not equal. A plus R squared is not equal to A times A plus K. This, it means, this mistake came from where? When I told in equation 1, G is square. When I told G equal to that, is square. Now I am telling no. My let was wrong. See? Not belong to N square. When G square equals 9 is good, but I told it is not square. Looks like 8. or 17 or 15 or 23 or 21. Then when you take the root of those, not square, becomes what? Not natural number. See? The G does not belong to a natural number. Then Euler perfect box does not exist. Why I told that? Because remember the theory is telling what? The first one, telling you all of those should be what? Integer. If you find one of them, like G, not integer, then no Euler. If D, not integer, then no Euler perfect box. Did you get it? I hope math judges and math professors invite me to talk why this fact is hidden. 7 years in my hand, I am asking for evaluation. And I sent to more than 30 math publications. All are telling me go find another publication or no answer. But secret went to them. I don't know why I am putting this my secret to the hands of who? Who's editor? Because we have many kind of people. We have people very honest, and we have middle honest, and we have zero honest. And I don't know. I'm afraid about my secret of Euler, Collatz, Fermat, general case. I need help, please. Second condition, A greater than R. And I know R always smaller than K. Okay, when A4, R should be smaller than A3. And K should be greater than 3. But there's no relation between K always greater than A. I know that. Okay. Let's go from here. Equation 3 again. Remember, I need to make those two equals. Expression. Go ahead, find left-hand side by substitution. And here also by substitution, AK, RK. We have AK and R. I did substitute. And this one I got 49. Right-hand side, I got what? 72. They are equal? No. This is proof for what? Prove that this expression is not equal to 2A times A plus K. This implies what? Because I did let this G square is really square, but now I am changing my mind. I'm telling you, no, I was wrong. It is not, see? Not belong to n square. When it is not square, G square equals 7. G is what? Under root. Not good. Not integer. Then no Euler perfect box does not exist with this condition. This is part A. Do you see part A? Part A. When we have different size. A smaller than B, smaller than C. This is part A. What happened if A equal B? Then what happened if A equal R? This is two another conditions. What happened if 3R equals? I have to go 3 more, okay? Very easy those. 5th grade student can understand, 5th grade. If I describe this, of course, I can make the would understand what I am talking about. Slowly, logically, neat work, patient, ask question. Do you have question? No. Then go. If A equal to R, I know this equation. Then what shall I do? Look at your picture. A equal R. A. This R became A. I have here 2A. Okay. A and R equal. I have 2 A's. This 4 Pythagorean for D became like that. This is 2. square it, 4a squared, and 1, 5a squared. This square this. What about d? Under root, multiply by a. Then this d, because it is not a square, the d is not integer anyway, d is not integer as you see, not integer, then the Euler perfect box does not exist. Does not exist. Okay. This what condition this was? When A equals R. What about C? A equal B. A and B equals. That means I have AA, this square plus A square plus A square. This square equals A square plus B square. Raise it up. This square equals 2A square. D equals under root of 2. And this one, it means not integer. Then the Euler perfect box does not exist. Okay? D. What happens if 3 sides are equals? A. I know from Pythagorean, this square equals A square plus B square. And A and A, B is A, became what? This square equals 2A squares. And D is what? A times under root of 2. Not integer. D is not integer. Then no Euler perfect box. Preferences. Some publication judging me with preferences of or with abstract, missing, please, or keyword. I did simple things. For example, here, my reference is what? Substitute number values, for A, B, C in order to prove two expression equal or not equal. This is one idea. Second idea, Pythagorean theorem, I use it. What else? By the way, Archive, this Cornell University has really announced a wrong solution of Euler from somebody. Publisher approved a wrong solution, not from me, by somebody else. There is no perfect cuboid January 12, 2024. Okay. I am telling, sorry, Archive, your proof is not is wrong. My proof, this is 100% correct, my proof. This is a third way. I will show you second way also, by the way. Author, Taha M. Muhammad, USA Kurd. I ready for competition. I ready or I am ready are the same. Look, I am done from this Euler third way. I hope you like it. I will put this on YouTube. If you have any comment, you can send me comment, please. God bless all of you. Thank you so much. Bye-bye. By the way, I need to thank you. The City Hall of Lakeville provided me professional camera and micro, see in my chest. I am talking to you. And the room from Senior Center, they respected me. I appreciate that. God bless America. God bless all of you. God bless entire world. We need peace in the world. God bless all of you. And that's why I am now at home. I was using simple tools, but this tools looks like a professional. I hope will come out well. Okay. How many pages I solved this one? 3 pages. If I shrink it, maybe 2 pages enough. See, I have a lot of gaps. Do you see? a lot of gap I have. But that's okay. God bless all of you, and thank you so much. I go stop the camera.